advice. Before you start writing on this, this is yours. You can keep it. But here's just a tip, okay? Listen, a tip for you is maybe write your answers. Maybe don't write on this. Write in the margin of this paper on a piece of scrap paper and leave this blank. That way you'll have the answers somewhere like a key, and then you can quiz yourself with this one later. So I can't give more than one copy out. Y'all know I'm way over my copies every month with this course as it is. But so maybe don't write on it. Write somewhere else. That way you have the key, and then you can use this paper to quiz yourself and have the same feeling of it as it's going to be. No, not the, no. It'll be different numbers and stuff, but same idea. It's going to look just like this, the same idea. Okay? So let's remember a couple different things. A lot of you did really, really well on the unit circle quiz. And I found one of my top students in my second period class, she was almost like in tears because she got a perfect score on this, and she wasn't making the connection between this and this. She could not understand what this was. And I sat with her, and she was like, oh, it's just the unit circle. I'm like, yeah, it's just the unit circle. Just not in a specific order, right? And so you guys know the unit circle now, I'm assuming, I'm hoping. What we have to break it down to, though, is when I talk about the ordered pair there, we have to remember that that's x and y, right? It's a point on the coordinate plane, but we have to think of it in trig language as cosine and sine, okay? So when I'm asking for cosine of an angle, it's the x value. When I'm asking for sine of an angle, it's the y value. Everything starts with the ordered pair. And we get our ordered pair from all of our denominators. And that's when we get into this, I'm going to just keep modeling that for you. Denominator gives me my ordered pair. Numerator tells me which quadrant, which gives me the SIGNs, right? The positives or the negatives. Then I decide, is it the cosine, which is the x, or the sine, which is the y? But there is one more added trig function on here that we don't have to know when we do the unit circle. But it's the easy ones. It's the tans, okay? The tans, so I'm going to review tan with you right now. You have to know the tan values for all of these as well. And it's pretty simple, okay? In your middle angles where you have denominator of 6, denominator of 4, denominator of 3, right? There's 4 of each of these. So what I'm about to cover covers 12 different tans. 4 6s, 4 3s, 4 4s, okay? Remember your choices. So this was memorization. These are your tan choices. You can have a 1, you could have a square root of 3 over 3, or you could have a square root of 3. Those are your options for all of these angles, except maybe that might be negative, and we'll go over that too, okay? So the easiest one out of those is the 1. Who gets the 1? Denominator of what? 4. So all 4 of your tans are 1 or negative 1, and we'll go over that, like I said, at all your denominators of 4. Okay, so memorization, know it. And then between these two, every year, I teach this every year, the same way every year, and I still get people confusing 6 denominator of 3. Where does the square root of 3 over 3 go? 6 or 3? 6. Guys, I know you don't think of adding. I mean, there's no place in our math world where we would add this 3 plus 3, but add it. 3 plus 3 is 6. That's how we know what goes there. All of my denominators 6 are this one. Well, that only leaves this one, which is the easiest one of all. This is this number. Okay? It's not even like, oh, the one that adds up to 6, you put on the... No. The one that adds up to 6 is the denominator 6. The one that is a 3 goes with your denominator 3. This occurs 12 total times on your unit circle. What changes is the quadrants and then what the sign is. So I want to just remind you that when I gave you these tan values, the way I came up with them was I did what tan is. Tan is sine over cosine, or you could think of it as y over x, right? Sine is y, cosine is x. And I did all this work. So I took the square root of 3 over 2, 1/2, I made a fraction out of it, keep, change, flip, rationalize the denominator, and ended up with these 3 answers, whatever the work was. But I did all that work. So when it comes to the signs, you have a couple of choices, okay? You can use this. Feel free to write that at the top of your little slip of paper if it helps you. And then you can say, okay, I know where everybody's positive, so by default, tan is going to be negative. So if you look at this, tan is positive in 1 and 3, right? All are positive, tan is positive. And in quadrant 2 and 4, tan is negative. So you could use that if it helps you. I don't really use that for this, me personally, just sharing what I do. I do a lot of drawing in the air. You are perfectly fine to do that, okay? For me, that's faster, because if I'm doing y over x, I know if I'm in quadrant 2, for example, I have a negative and a positive. If I divide a negative by a positive, I get a negative, right? If the signs are the same, you get a positive answer. 4 over 2, or negative 4 over negative 2. If the signs are the same, you get a positive answer. If one of them is negative, you guys know this, it doesn't matter which one, you get a negative, okay? So you decide how you're going to come up with whether it's positive or negative, whether you use all students take calculus, or you just think about what order, where it is on the coordinate plane, okay? So that's 12 of them. Then we get to the quadrantals, okay? Here's a tip for you I haven't mentioned. I just thought of it last period. Optional, I just like to throw things out at you. Just like this is something, if you want to draw that at the top of your paper, you could also do this. Draw a quick quadrantal graph. So do this one time. To the right, 1, up or down 0. That one's negative 1, 0, 1, 0, negative 1. Done. That way, anytime I get a quadrantal question, I can just look at this. Okay, this is cosine, this is sine. If I do y over x, I'm going to go through those all. But that's what you could point to, right? Because I've told you, quadrantals is where I see the most mistakes. Most mistakes happen right here, okay? So let's talk about 0, pi over 2, pi, and 3 pi over 2, the tans, okay? You can either write that ordered pair down when you see it, or if you wanted to use this trick, I like this because as you'll see as we go through this, there's quadrantals are on here several times. So I don't have to keep coming up with the ordered pairs. I do it one time, and I can just reference this anytime I get one of my quadrantals. So remember, tan is y over x. Y over x. That's 0 over 1. Make sure you simplify it. If you leave it like that, it's wrong. 0 divided by 1 is 0. Okay? Pi over 2 is up here. Y over x. That puts 1 over 0. Never allowed to have a 0 in our denominator. That's undefined. And so on. 0 over negative 1. 0 on top. We good. And then at the bottom here, negative 1 over 0. Undefined. So your choices are pretty limited. At your quadrantals, your tans are either 0 or undefined. You could even say undefined, undefined, and then you know these two are 0. Like whatever tips that you want. I'm handing you a blank piece of paper and giving you 3 minutes. What I would not advise you to do, and I have seen students do it, is they try to draw the whole unit circle. You're not going to have enough time to draw the whole unit circle and then pull from it. If you know the unit circle well enough to just draw it here and put all the information, then it's in your brain. Find it in your brain. And now I'm going to show you what I mean by that, okay? So you get this paper, same deal, name on the back, turn it over, timer starts. I hardly even look at anything. My eyes go right to my denominator, okay? And then at quick glance, the reason I want to see what it is here is because if it's a tan, I don't need the ordered pair. I have a trick for all my tans. The minute I see a denominator of 6 and a tan, I know what the value is. I know it's square root of 3 over 3. But is it going to stay positive or become negative? That's when I have to look at the numerator, okay? The numerator now tells me I'm in quadrant what? 4. We know that quickly, Evan. Why? Because it's improper and the difference is more than 1, right? 11 minus 6 is 5. And improper fractions are here or here, right? How we know it's not here is the difference is 1 here. If I subtract these, it's 1. The difference here is 2, 3, 5, something other than 1. So I'm in quadrant 4. So you're either using this to help you to know if tan is positive or negative, or you draw in the air or in your head, positive, negative. Those are two different signs in that quadrant, which is going to make a negative here. Or again, this tells me cosine is positive, so by default, anybody else is negative. Okay? Maybe I do this at the beginning too. Now all my quadrantals are on here. Tan of 0. Here's 0. So that's 0 over 1. You have to remember it's 0 over 1. 0 on top, 0. This is the process I go through, guys. I don't do it any faster than this. Exactly what I'm doing right here is exactly how I find the answers. It doesn't have to be lightning quick. Denominator of 2, oh, that's a quadrantal. Lucky I drew this, right? Here's my ordered pair. Sine is the y value. There we go. 3 pi over 2. Remember, denominators of 2 are quadrantals, top and bottom. 3 pi over 2 again. Cosine would be the x value. Okay? Another tan. Denominator of 4 with a tan. Quick, what's the answer? 1. Now we figure out the sign. Quadrant what? 2. We know this is quadrant 2 because the numerator is 1 less than the denominator. If it was 5 on top of 4, that's 1 more, that's quadrant 3. 1 less is quadrant 2. Negative, positive, it's going to be negative, or using this trick, quadrant 2, sign is positive. By default, everybody else is negative. Okay? Another tan. I see a denominator of 3. I know it's square root of 3. I give you credit for getting this right, even if the sign's wrong. Okay? So you just memorize those tricks. You got the answer. We're in quadrant 1 clearly. Everybody's positive. In quadrant 1, I'm good. Denominator of 4 gets me my ordered pair. Numerator tells me I'm in quadrant 2. Cosine is the x, sine is the y, and sine is positive. So this is negative, this is positive, right? Negative, positive, or again, sine is positive in quadrant 2, if that helps you. Figure out what works in your brain. Everybody's got their own way of doing things. Pi is a quadrantal. It's right here. Sine of pi, that would be the y value. Done. Denominator of 6 is square root of 3 over 2, 1/2. Did I need to write the whole thing? That's a personal question. Remember this annoying thing I keep giving you is to remind you that denominator of 6 is the first angle, square root of 3 starts the party. So the minute I see a denominator of 6, I already know this ordered pair pretty well. And this is cosine. I didn't need to write this to remember, what is sine going to be? Okay, so if you're worried about time, you could, prevent yourself from having to write so much. But if it helps you, write the ordered pair, find the quadrant. Of course, this is quadrant 1. Sine is the y value. My answer is 1/2. That's the process every time. So here it is, last one. Denominator of 6, I go, okay, square root of 3 over 2, 1/2. Numerator, that's a quadrant what? 4. Positive, negative. So this is negative, that's positive. Cosine is the x value. There she is. Okay? So if you know the unit circle and you just study again a little bit those tan tricks, you should be fine with this. Right? Are we feeling a little bit okay about this? You need to test yourself. And we're about to do it again, really, in our notes right here. So here's another opportunity to quiz yourself, see what you know. I'll try and go slowly when we get to this so you can kind of give you a chance to ask yourself the question. All right, so we're on page 41. And again, you're going to feel like these notes are just like yesterday's. So if you weren't here yesterday, which was a chunk of you, exactly what we're doing today is what we did yesterday with one minor difference, and I'll tell you when we get to it. For those of you that were here, it's a different pattern of our points. So today we're graphing the cosine function. We can call it a curve, a wave, a graph. Here's the difference from yesterday. Instead of sine, which is the y values, cosine is the x values. So we have a table of values here, and just like yesterday, we're only going to have to do a table of values here to kind of learn about it. We're never, ever going to have to make a table of values again to graph cosine. And so let's start with that. So just like yesterday, our x values are our thetas, and some are picked for us. Again, these are the quadrantals, the denominators of 6 and the denominators of 3. Plenty of points, okay? And then what we're going to choose here is the cosine of each of these. So use this as an opportunity. Like I said, I'll try and go a little slower so I give you a chance to find it in your brain. So we're at a quadrantal here. Think of what the ordered pair is and then grab the x value. So the ordered pair at 0 is 1, 0, right? And cosine is the x value. These two are quadrant 1, right? They have a numerator of pi. These are quadrant 1. And 6 is the first one I come to. Who starts the party? There you go. And so denominators of 3 are the opposite. Remember, if you know 6, you know 3, because it's just the flip. All right? And everybody's positive in quadrant 1. Here we're at another quadrantal. See if you can come up with the ordered pair in your head. Write it, think of it, whatever. That would be 0, negative 1. So cosine is 0. Now we're in quadrant 2 here. How do I know that so quickly? Numerator is 1 less than the denominator, right? And we already established that denominators of 3 start with 1/2. Denominators of 6 start with square root of 3 over 2. And in quadrant 2, cosine is negative. And there's no shame in drawing your little points in the air. It really does help this math teacher who is good at this stuff. There's too much going on. So it helps me to put my finger in the air. I'm putting my finger right here. And I'm going to this quadrant. So I'm going negative, positive. That's what I'm saying to myself. Negative, positive. And then I can assign those points. Okay, so negative on the cosine, fine. Another quadrantal over to the side. See if you can come up with it. I'm going to the left 1 and up or down 0. Cosine is the x value, so that's negative 1. Gets us into quadrant 3. How do I know quadrant 3 so quickly? My numerator is 1 more than the denominator. Again, quadrant 2, 1 less than the denominator. Quadrant 3, 1 more. Denominators of 6 always start with the square root of 3 over 2, so the denominators of 3 are the other ones. And quadrant 3, cosine is negative. Gets us to our bottom quadrantal. Remember, our two denominators of 2. There's only 2 of them, the top and at the bottom. So pi over 2 at the top, 3 pi over 2 at the bottom, 0, negative 1, so cosine is 0. Almost there. We're now in quadrant 4. Again, numerator is bigger than the denominator by more than 1. Okay? So again, quadrant 3, quadrant 4, both are improper fractions, but in quadrant 3, the difference between them, if I subtract them, is 1. The difference here is something other than 1. And my denominators of 3 are 1/2. My denominators of 6 are square root of 3 over 2. And cosine is positive in quadrant 4. And then we get back to where we started. Remember, periodic graphs always start and end at the same place. 0 and 2 pi are coterminal. They have the same ordered pair, so they have the same sine, cosine, tangent. Okay? Now, I'm not going to bother with all this. Yesterday, we talked about where it's increasing and decreasing and max and min. I'm not going to go through all that again. But remember, just like yesterday, we came up with a whole bunch of points, and then we zeroed in on 5 key points. On sine graph, 5 key points. Cosine, 5 key points. The first one and the last one are good ones. The one in the middle is a good one. And then in the middle of those is good. If you notice, they're nicely spaced out, and we don't have to graph any fractions. All of our y values are 1, 0, or negative 1. So, just like yesterday, let's go to the next page and look at the graph of the parent function of cosine. And just like we just talked about, there are 5 key points, and we're going to write them right here. So the 5 that I just highlighted, I'm just taking them right from that chart. You just want to steal mine. Now remember, you're never going to have to actually use these ordered pairs. This is just me being a professional math teacher and teaching you the why of what's happening. We just went through that huge table of values. We picked out 5 nice and easy points. And these are our parent function starting points. And then we start throwing the A and the B and the D and later on the C in there. And it changes these points. But if we just know the pattern, we don't really have to use the points anymore, just like yesterday. So what am I talking about? All right, our first point is at 0, 1. Second point is pi over 2, 0. Pi, negative 1. 3 pi over 2, 0. 2 pi, 1. There's those 5 key points. All of the other ones we found and ones that we didn't find are in there, right? They're in between. But using those 5 key points and then connecting them and making a smooth curve covers all the points. So this is a new pattern. If you remember, sine started in the middle. It was middle, up, middle, down, middle. The only difference between yesterday's notes and today's notes is that. Here, look at our pattern. It's up, middle, down, up, middle, down, middle, up. So that's really something you have to memorize. Sine starts in the middle, cosine starts up. And we get flips, right? So you want to start really, as you work on today's homework, keep saying this pattern. Cosine is up, middle, down, middle, up. And when you do sine, because in a couple days we're going to put them together in one assignment, so you'll have them mixed in together. All the way we graph it is the same you're about to see. It's just this pattern that's different, okay? So just like with sine, the domain is all real numbers. We just graphed one period in that picture, right? This is one cycle or one period, and it goes from 0 to 2 pi. But it keeps going. Like you could keep making that forever and ever, right? That's what this means. It goes on forever in both directions. The range of the parent function, our min is at -1, our max is at 1. Amplitude, just like with sine, is always positive. It's how high and how low, where our min and our max are. The period, we have those same 2 formulas as yesterday. Nothing has changed. Period and B, so we're going to start introducing B now. B is the number hanging out with X, and it affects the period. So in the parent function, B is 1, right? There's a 1 there. So whenever B is 1, our period is 2 pi. The minute we start putting different values in there, it will affect the period. So we have a formula to find the period, or you have a formula to find B. You're always going to be given one or the other. You're either going to have B because you have the equation, you just pull the number out, or you're going to have a graph and you can tell what the period is. You're always going to need the other one. So anytime you have to find period given B or find B given period, you always just do 2 pi divided by what you have, whichever one you have, and it'll give you the one you want. It's nice because they both have the same numerator. So all of that is the same as yesterday. Again, the only difference is our pattern. Instead of middle, up, middle, down, middle, we have up, middle, down, middle, up. That's it. That's really the only difference in yesterday's and today's. So we're going to do 3 quick graphs, and then you'll have lots of time to work on your homework. I'm going to quiz those people that are getting quizzed today. So here we're going to graph this. The first step in all graphing is to pull out any of the letters given, okay? So we have A is 1.5, right? What's B? 1. There's a 1 in front of that X. So to graph, I need A and I need my period. I need to know how much of the x-axis I'm going to use to make those 5 points. Remember, you don't see period just by looking at the equation. We see B, and then we can find period. Remember, it's always 2 pi divided by the thing we have, which is B. That's 2 pi. So we know from yesterday that anytime B is 1, it's just like the parent function. Your 5 points are going to be spread evenly from 0 to 2 pi. And now we're ready to graph it. Instead of graphing these points, and we are going to come up with the rule. So let me back up. Let's do the rule. Because I think that even though we're not going to come up with all the points, it's important to know this, how each number affects the ordered pair. So there's those 5 key points, x and y. By changing the 1.5, this to a 1.5 versus a 1 that was in front, it's going to stretch vertically. It's going to affect the y values. The x values are not going to change. The y values will get multiplied by 1.5. You might remember anything that's inside the parentheses with the x affects the x. Anything else affects the y. So we'll see that a couple different times. Okay, so you could take all of your starting points and multiply all the y's by 1.5, but we don't have to do that. We just know that instead of going up to 1 like in the parent function, we're going to start at 1.5. That's how high I'm going to go and how low. And the pattern is up, middle, down to 1.5. There's my min. Middle, and then up. And there it is. It looks like a V, but as you saw above, you need to make it curvy as best you can, okay? It is not a V. It's a wave. It's curves. All right? Good. Let's try another one. All right? First step of graphing, pull out the A and the B, and if you have a C down the road, a D, whatever it is, just pull out all the numbers. Sorry, let me do that. So A is going to be 2. Remember, amplitude is always positive. The negative in front is just telling me I'm going to have to flip. I'm going to go over that again in a second. B is 1/2. That's the number in front of the X. B is not the period, but it affects the period. I need the period. I need to know how wide this is going to be. We always start with 2 pi in our numerator and divide by what we have. In this case, it's b. This is keep, change, flip. So it becomes keep 2 pi, change division to times, and flip 1/2 becomes 2. So our period is 4 pi. We're ready to graph, but let's write our rule just for fun. Anything in the parentheses affects the x. That's it. Anything else affects the y. Don't forget this, though. When it's in the parentheses, it's opposite, right, left and right. We'll see that in a couple days. But also that number. This is a horizontal dilation by factor of 2. You have to flip it inside. And then the -2 gets multiplied by the y values. So this affected the y values. This affected the x values. Don't forget to flip. All right, so you could do this, but I think it's easier to just say, okay, I'm going to go from 0 to 4 pi, right? That's how wide it's going to be. And I need to break this up evenly. So sometimes it makes more sense to kind of put your first and last point on and break it down like that. So cosine is normally up, middle, down, middle, up. But if it's a flip, we're going to start where? Down. We'll start down. So we're going to go down, middle, up, middle, down. And we always start and end at the same place. So that kind of gives me my end points, right? 0 to 4 pi. Right in the middle, so this is down, middle, up. So my middle point would be 2 pi. That's in the middle of 0 and 4 pi. That would be up at my max of 2. And then in between 0 and 2 pi would be a middle at pi. In between 2 pi and 4 pi, in the middle is 3 pi. So sometimes it's helpful to just space it out like that. And then curvy graph. Right, last one. There's that A. A is 3, no flip. B would be 1. And remember, we haven't learned C yet. That number far to the right is called D. It's like your K value, A, H, and K. It moves all your points up or down. It's also called the midline. D is your midline. So real quick, let's do our rule. Nothing in the parentheses. Nothing's changing the x's. But we'll multiply all the y values by 3. And this is on the outside, too. It's going to affect the y values. That's just -2. It moves all your points down 2. That's all that does. And you guys, sometimes when you have graphed other functions, we would like graph the parent function and then move all the points left, right, up, or down. It's so much easier with sine and cosine. If you have a midline, put that in first, okay, and use that as your middle, okay? We didn't have to do that on the last ones. 0 was our midline, right? So we just started there as our middle. Now use this as your middle, and then you don't have to do any shifting. So no flip, I'm not going to have to, what's my period? What's the period going to be, guys? 2 pi. Because 2 pi divided by 1 is still 2 pi, right? So I'm going to make all 5 points from 0 to 2 pi. So I'm going to start up at 3, but up 3 from here. So be careful. This is our new, think of that as your new x-axis. So go up 3. Actually, we're starting at positive 1. So there's my up. Here's a middle. And then down, how many from the middle? 3, right? And then middle, and then up. And that's easy to check if you did it right. Remember, amplitude is 3. From here to here should be 3, and it is. And from here up is 3 as well. Okay? And that's it. All right. So let's go to page 46. I'll do 2 with you. I'm not going to do the whole bunch like I did yesterday. Because remember, 1 through 4, just like yesterday, we didn't have any like that on the in the notes. All right, so 1 through 4, you're given a graph, and what we're going to do is, these are the things we can pull right off of the graph. We can pull the amplitude off and the period. That's all we can get off of it. And then we're going to write an equation given that information. Don't worry about describing the transformations. So starting with A is always the easiest, right? It's our max and our min. And remember, if they're the same number, then our middle is 0. So that's 2. Let's decide, no, A is never negative, but let's decide if there's a flip. So you can kind of kill 2 birds with 1 stone. We can find the period and decide if there's a flip just by counting out our 5 points. So here's a first point, but it's down. So down, middle, up, middle, down. That is 1 period, and it goes out to 4 pi. Right away, Zach, yes, we know this is a flip. Positive 2 with a negative put out in front is how it's going to look. So just remember, I don't want you putting a negative here. Even though if you do, this is your work, it's not my business. You can write negative 2 here, but remember, if you're ever asked, what's the like just a multiple choice question, what's the amplitude? You would say 2, not negative 2. Okay, that's why I'm trying not to have you do that. All right, the period is how much of the x-axis we just used. From 0 to, is that 4 pi? But remember, I need A and B. The period and B are not the same, they're just related. So remember, the formula is always putting 2 pi on top divided by what you have will give you what you need. So it's always 2 pi on top. And then you either put B or period in the bottom and simplify and give you the other one. Ready to write our answer. Y equals amplitude of 2 with a flip. Technically, it's really this. That's really what you're seeing, okay? But we condense it mathematically, but it still means 2 is positive, okay? This is a cosine graph, and then if there's a b value, we're going to put it in parentheses with the x, just like we did yesterday with sine. Same exact steps. Good? Okay. So amplitude, we're up to 3, is that 3? Down to 3? And yours are probably just as bad as mine. Yeah, that's 3. Okay, so amplitude is 3. Let's see if there's a flip and find the period all at one time. We're starting up, no flip here. Up, middle, down, middle, up. You got to know those 5 key points. That tells you the length of the x-axis you use for one cycle. So our period is pi, but we need B. Remember, B is 2 pi always divided by what to have gives you what to need. Three cosine 2. Okay? This amplitude, just so you know, is 2.5. It's hard to see it, and there is a flip. I'm going to put the key in. In 9 through 12, I do want you to write the rule. Okay? I crossed out, but then I wrote do. We'll see if you do it. I didn't make you guys do it yesterday, but if you're taking a 5-minute quiz, I'm going to ask you guys to get your own phone and set a 5-minute timer for me. So if you are taking the quiz, go ahead and grab your phone and set up a 5-minute timer. And I will come and see you. Write your name on the back, that way you don't have anything. You have your 5-minute timer. Everybody has their 5-minute timer. Oh, good.